Hi everyone. All right, so today we're going to talk about greatest common factor of a polynomial and how to find that. So you should be able to identify and factor the GCF of a polynomial. So I want to review what a greatest common factor is. So a GCF, okay, a GCF or greatest common factor, okay, our definition that we have is the largest common factor of two or more given terms. Okay, so I say terms instead of numbers because we're going to be looking at terms with variables and coefficients and all the exponents and stuff. So I don't want to just say numbers. So an example of what this looks like is when you have 16 and 40 like we do down here. When you learned this before, we learned that we would list out the factors of each term. So I'm going to list out the factors of 16 and I'm going to list out all the factors of 40. So when I do that, I should have a nice little list, and I like to keep mine organized in a way that they go from least to greatest. You can list them out with the pairs, so like 1 and 40, 2 and 20, and things like that. So the greatest common factor for 16 and 40 would be the biggest number that they have in common that's a factor. So here, if you look, they do have 1 in common, they do have 2 in common, they do have 4 and 8. They don't have 16 in common. So the biggest number that they have in common here is this 8. So we can say that our GCF for these two numbers is 8. So we're going to do something similar, but we are going to do that with variables as well. So if we take a look at example 1, it says find the GCF of each pair of monomials. So we have two monomials that we're comparing. So for 18x cubed and 27x squared, we can set it up the same way if you'd like, where we have the two factors listed and we're going to kind of pick it apart. As you get better at this, you won't do this step because it's going to be a little longer. Eventually, you'll just be able to look at it and say what they have in common. So for 18, I want to look at the factors at 18. So I have 1, 2, 3, 6, 9, and 18. And then there's also this x cubed. I'm just going to put it off to the side. I'll put a little and here. So 27, same thing. We have 1, 3, 9, and 27. And then I'll put an and because I have an x squared. Okay. So the biggest coefficient that they have in common, or the biggest factor that these coefficients have in common, I'm sorry, if you look, they have a 1. They also have a 3. But if you look, they have this 9 right here. Okay, they don't share a 6. Okay, they don't share an 18. They don't share a 27. So this 9 is really what you're looking at. But now that we have variables, we also need to take a look at what else they have in common. So we need to take a look at these x's. So for the x, how many x's do they have in common? Well, when you take a look at the variables, you're always going to look at the power, okay? So for our GCF, we know we have a 9 as our coefficient, but how many x's do we have in common? Do we have 1? Do we have 2? Do we have 3? It's going to be the highest number that they share. So what I mean by that here, this is x times x times x, and this is x times x. So we have x cubed and x squared. We've written them out, so they're kind of broken apart. So this x has 2 x's, this x has 3, but they share a maximum of 2. So the GCF here would be 9x squared, okay? So when you look at your variables, look at those powers and see what the maximum they have in common. You can't say that they have 3 in common because this little guy down here doesn't have 3, it only has 2. So that's why we say 2 instead of 3. So I want you to go ahead and try part 2 on your own. So go ahead and do that now. So for number 2, the GCF that they have in common is 5x to the 4th. So if you look at the factors that are available, they don't have a 20 in common, they don't have a 45, they don't have a 10, they don't have a 15, they don't have a 9. You're looking at these 5s right here. So then if you look at the x's, if you wrote it out, you've got 4 x's multiplying together, which is what x to the 4th is. X to the 5th is 5 of those x's multiplying together. So if you only have 4 up here, you can only have 4 in common down here. So that's why our GCF is 5x to the 4th. Okay, so moving right along, we're going to find the GCF of an expression now. So we're going to use the same idea and we're going to factor it out, take out the GCF because that's our first step of factoring, and we're going to simplify this expression. Okay, so we're going to take a look at the two terms we have. So we have negative 14 x to the 3rd, and we have really negative 18x squared. So what's important is that if they're both of your terms or all of your terms are negative, you can already say that they share a -1, and that has to come out. You are always going to take that negative out because your first term should always be positive when you factor. Okay. All right, so we took out the -1. If they're negative, you need to make sure you take that out because as I said, this first term should always be positive when you factor. And then you can list out all the other terms. So for a positive 14, 14 has, a 1, which is the -1, 2, 7, and 14. And then we also have this x to the 3rd. And then 18 has, we've already done this, a 2, 3, 6, 9, and then 18. And then we have an x squared. So the process isn't any different, but when you have negatives, you need to be careful about them and make sure you factor that out. So for number-wise, the factor that they have in common, if you look, is this 2 right here. Okay, and this -1. We're going to partner them up. So we're going to pull out the negative and bring out the greatest factor that they have in common. And then if we look at our exponents, we have x to the 3rd and x squared. They have this x squared in common because that's the greatest exponent we have. So up inside here, I'm going to just write that my GCF is a negative x squared. So then when I factor out the expression, okay, when you factor out with an expression, you're essentially dividing this factor out. So if I took -14 cubed and divided it by -2x squared, how would that simplify? So when you divide this out, I know that my negatives cancel, okay? 14 divided by 2, I have 7. It goes on the top. I'll just get rid of this fraction right here when we do that. I have 7. And then from your division rules for exponents, this is now 3 minus 2, which I'm left with an x to the 1st. So my first term is now going to be a 7x. And I'm going to do the same thing with my -18x squared. I'm going to divide it by -2x squared, and I'm going to simplify it. So I know the negatives cancel because negative divided by negative is positive. 18 divided by 2 is 9. And then x squared over itself, that cancels to be 1. So now this is a positive 9 as my answer. So now this is my final answer right here, -2x squared times 7x plus 9. That is completely factored, and you can check it to make sure. So if I rewrote it down here, and I'm just going to do it real quick, 7x plus 9, distribute it in, -2 times 7 is -14, x squared times x is x cubed, -2x squared times 9 is -18x squared. So as long as it matches your original expression that we have up here in the problem, these match, then you did it correctly. Okay, so it doesn't matter how many terms you have, as long as you take out your GCF, you divide it out, and then you don't miss anything when you rewrite it. So I want you to go ahead and try number 4 on your own. I want you to find your GCF. Okay, so you're going to find your GCF, and then you're going to factor. Okay, so you have 2 parts to this. You're going to find your GCF for all 3 terms. Okay, so for all 3 terms, and then you're going to factor the expression. So go ahead and do that now. So for number 4, your final factored form should be 4x times 3x squared minus 2x plus 7. So your GCF here is 4x. So when I list out my factors, which again, as you guys get better at this, you won't need to do this because you can see this is a lot of work. Okay, so just make sure you're trying to master this part of it, because then you won't have to do the baby steps anymore. So I can see from my list that they have the greatest number they have in common is 4. And then the greatest power of x they have in common is this just x to the first. So that's where the GCF comes from. And then I take my fractions, I take my division, so the 12x cubed minus, or divided by 4x. 12 divided by 4 is 3. X to the third over x to the first. 3 minus 1 is 2. Okay, so exponent properties, they didn't go away. Negative 8 divided by 4 gives you this negative 2. And then x squared over x to the first, 2 minus 1 gives you 1, so negative 2x. And then my last term, 28 divided by 4 is 7. X over itself cancels to be 1, so you're just left with 7. So that's where we get our boxed answer from. Okay? And then just one last thing before we move on. If you cannot factor, if there's no GCF, there's nothing you can factor as we go through our unit, then that polynomial would be considered to be prime, okay, and you would just write prime. So if you cannot factor, okay, if you cannot factor, then you would say it's prime. Okay, so let's go to the next page. So we're going to factor out a binomial expression. So we don't just have a GCF that's a number and a variable. We have a binomial expression. So for number 5, I have 4x times x plus 5, and then I have minus 9 times x plus 5. So you can physically look at this and say, well, they both have this x plus 5 in common, so why don't I just take that out? So if I take it out, because that's your GCF, my GCF here is this x plus 5. So if I have 4x times x plus 5 and I divide out the x plus 5, okay, multiplication rule says this cancels, then I'm just left with a 4x. So in my last problem, I wrote the GCF out front, and then I would start to write what's left inside, so 4x. And then if I took negative 9 times x plus 5, and then I divided out the actual binomial, the x plus 5, these cancel because they are the same, exactly the same, there's no difference. Then you're left with negative 9. And then that's your answer. Okay? So when you have something that isn't a monomial and you're trying to factor it out, this is the same process. It follows the same process as a monomial. It just looks a little different. I want to take a look at number 6 with you before I ask you to do it because it's a little bit more complicated. So number 6, you have 2x times x minus 3 plus 5 times 3 minus x. So you can see that this binomial and this binomial are very similar, but they're not exactly the same because the signs are opposite. X in this first one is positive, here it's negative. Here 3 is negative, here 3 is positive. So a little trick, okay, a little trick for this problem right here, okay, and this is a good little trick to know, is that, let me put the arrow, because it's for this one, okay, right here. So a good little trick for this is if I need both of these to be x minus 3 or 3 minus x, whatever I choose, I can take out a -1. So if I took 3 and divided it by -1, I now get a -3. If I take negative x and divide a -1, I now get a positive x, which now leaves me with negative parentheses x minus 3. And if I wanted to check to make sure my work was correct, if I distributed the negative back in, I have negative x plus 3, which is the same as 3 minus x, which is what I started with. So I know I did that right. So the little trick here is that you can factor, you can always do this, by the way, factor out the -1. So now what I'm going to do is I'm going to rewrite this problem with the -1 factored out. So if I take this out, I already have a 5 out front. 5 times -1 is -5. And now I have two binomials that are exactly the same that I can factor out, I can divide out, and then if you notice from the last problem, what's left, okay, gets put into the second binomial, okay? So when we were doing all this work, I'm hoping that you're noticing how the math works out, that you can see when I divide it out, I'm left with the term that I started with. Okay, so hopefully you're picking up on those patterns and those cues, those little shortcuts. So you don't have to do it necessarily exactly the same way every single time, because you do have this option of just it, you know, you're taking it out and you end up with what you start with. Okay, so my answer here is this x minus 3 times 2x minus 5. Okay, so we'll do a lot more with negative. So if you're not 100% on that one yet, that's okay. We're going to do some more practice. The video is getting a little long, so I'm going to have you do just a couple practice problems on your own, and then we'll call it a day. So I want you to go ahead and do number 2, number 5, and number 6. Okay, so when you're done with those, you can check your work. All right, so we're going to do more of this in class because, again, this is getting a little long. I don't want to go too much longer. Please check your answers. Note if you have any questions or you're confused about the answers, and we'll talk about it in class. I hope you guys have a good day.